everyone, my name's Louisa and I'm just going to be introducing you to Ohm's Law today. So we're going to talk a little bit about what it is, what does it mean, and how does it work. Alright, so conceptually, Ohm's Law is the relationship between the voltage, the current, and the resistance. So let me just write that down for you. I'm using the symbols for voltage, current, and resistance, which as you probably know are V, I, and R. And it allows us to calculate any one of these as long as we know the other two. Sorry, just writing this down. And now you're probably wondering what the mathematical relationship between these is, and that's definitely going to be very important to you as you're studying physics. So the mathematical representation of Ohm's law is simple. It's V equals I times R. This can be written a couple of different ways. For example, if we divide both sides by R, we can write it as I equals V over R. Or if we divide both sides by I, we can write it as R equals V over I. Whoops, I almost made a mistake there. And now all three of these are actually the same equation. Let me just make this a little bit easier to read so that you know it's a V. And all three of these represent Ohm's law. That said, this is by far the most popular and often the most useful form, so we're going to mainly be looking at that. Now, when we're looking at what does Ohm's law mean, one of the most important things to consider is which quantities are directly related, directly proportional, and which are inversely proportional. So let's write this out one more time. We've got V equals I times R. Now V and I are on opposite sides of the equation. That means that if R doesn't change, an increase in V will lead to an increase in I. So V and I are directly related. I'm going to start a column of this. So V and I. V and R are also directly related because they're on opposite sides of the equation, and if I is constant, an increase in V will lead to an increase in R. So V and R. Now, I and R are on the same side of the equation and they're multiplied together. So that means that if V is constant, for example, just to keep things simple, let's say that V equals 1. If I equals 5, then R equals 1 over 5. If I equals 100, then R equals 1 over 100. So as I gets bigger, R must get smaller, and the reverse is also true. If R were to get bigger, I would also have to get smaller. So that's called an inverse relationship. They're called inversely related or inversely proportional, and I and R are inversely proportional. So if we want to take a little bit more of a look at why this is true, these are all sort of trends that we can understand on a conceptual level. Let's talk about voltage and current. If you think of voltage as sort of the force pushing on the electricity, sort of pushing it through the resistance that it's going through, then it makes sense that an increase in that push will lead to an increase in the speed at which it's traveling. Likewise, if it's going at a pretty fast speed, you can imagine that there's probably a pretty strong force, a pretty strong voltage. So that one makes sense. Voltage and resistance is a little bit trickier to understand, but you have to think about it this way. When we're talking about the relationship between V and R, we're assuming that the current is constant. So we know that the electricity is flowing at a constant speed. That means that if the force is really high and the current is the same, there must also be a pretty high resistance that's pushing back on it to keep the current from going way, way, way too fast. Or, if the resistance is very low and the current is constant, then the force pushing is also pretty low, or the voltage is pretty low. So that's another one you sort of have to wrap your head around a little bit, but think of it this way. The less impedance there is to the flow of electricity, the less pushing you need. So that's why voltage and resistance are directly related. And current and resistance are inversely related, and that makes sense because it's pretty simple. The more resistance there is, the harder it is for current to flow, and the more slowly charge is going to flow through. So that one we can understand as well.